Hello my friends, in this short video I want to explain to you how you read data from Etherscan.io, which is a famous block explorer for Ethereum. And we also talked about the transactions and block data in the last video. And in this video I want to show you how you read information that contains or that belongs to your account or to an account from a person, for example. So this is called externally owned accounts, or to a smart contract, which is a contract account. So as I said the last time, we have on Etherscan.io, we have these two sections. So the left section is blocks and the right one transactions. And you see, for example, for a transaction, we also reviewed this the last time. So for example, this transaction is, when I not mistaken, a classical transfer. So somebody transfers 121 US dollar from this account to this account. So this is two persons actually, or two external owned entities. And when we go to this account, we can click on this or on that. So it doesn't really matter. So let's open the first one. Let's open the second one, where we'll see this amount of ETH going in. So 0.1 Ether is sent from this to that. So let's copy this address and go to this account. So we will see that this is an externally owned account. So no contract, no source code, no contract section here, and also no information here. I will show you another example where this is not the case. And we see that there is one incoming transaction on this account from this one. So I copied it so we can search for it and find it. So this is the same information as we have before. And here is the 0.1 ETH that is ingoing. And you now see that this is an account that has 0.1 Ether as balance. And yeah, this is not really exciting because there is only one incoming transaction and nothing else happened here. So I also opened another one. So let's go back here to the starting page and let's review this account. So this is another one. I opened it before I started to record the video. And we see, for example, that this has a current balance of 0.167, which is about 202 US dollar. And this account has some tokens. So it has Tether in his wallet and not less, so 250,000 USDT, which is of course 215,000 US dollar, because it's a stable coin. I'm sure you know. So you can see how this is going to, so the incoming and outgoing transactions. So this is all the history about this account. So 7 days ago, the account from Binance. So basically this guy has an account on Binance and he transferred 0.178 to ETH to his own account, or maybe to another one, to another person, but most likely this is the same person. And then you see 1, 2, 3, 4 outgoing transactions. And one time he sent a transaction to USDT, to the smart contract of USDT, another one. Basically he was trying something, I don't know. And then he sent twice 0.005 to this account. And yeah, we can now follow along the chain or all the linked and hashed information. So we could click to this. I will do it very quickly and see, okay, this guy has 12 US dollar and 78,000 also of Tether. But let's don't lose it because this is going on for almost quite a long time. We can follow along the money here. And I'm going back. So this is all the ingoing and outgoing transactions on this account. You see some ERC20 information, which is basically this Tether. So Tether is a ERC20 contract or token, which is tied to the US dollar. And you see that this is one incoming transaction. So this account received 245, and then there was two outgoing transactions. So one with 30,000 and one with 795. And this, he sent, for example, 30,000 US dollar to this account, and we can go again to this account and can have a look what's the current status here. So this guy still has the 30k US dollar, and this is only one incoming transaction again from this one. So when I click on this, we are back to the previous one with the 245 or currently 215. So this is how you can navigate back and forth on the chain and on the chain and on the transactions, so you can really follow along the money here, and it's quite interesting to see. So this is basically an externally owned account. So as I said, externally because of there is a external private key that controls this address or controls this account. So basically a person or another entity, but most likely a person. And let me close this. And here I opened another account or another transaction basically, where some token mints took place. So for example, somebody sent a transaction which is not a transfer of money, but which is an interaction with a smart contract. And here, for example, this guy, so basically it's the from, this is the 0xDC27 and so on, which is basically also stored as an ENS, so Ethereum name service. So behind uomo.eth, this address is configured, and you see that this interacted with a contract. So the two here is not an account as the last time. So this is a smart contract here, and you see what happens. So the tokens transferred. So basically it's 1, 2, 3, 4, 5 mints. You see this because of is there some mint information? No, you see this because of the so you see a transaction from an address to an address, and this to address is basically a contract. It's also verified or identified here, and it's a verified one because of the green tick. I will explain a little bit more about this in a few seconds. And you see that the interaction or the result of this transaction is a mint or are mints of tokens, so 5 ERC721 transfers basically, and it's a mint because it's from address 0, so all zeros here, to a certain address. And this one is again this, when you have a close look, it's 0xDC27, 0xDC27. So this guy sent a transaction to a smart contract to this address, which says, hey, please, smart contract, mint 5 tokens for me and send it over. Okay, and this is how you read it. So this contract is called encryptables. I will click on this in a few seconds because, or in other words, I already did, but I will show you in a few seconds. And you see that now, as I said, 5 mints took place. So from address 0 to this receiver address. It cost 0 ETH. So basically it's a free mint as it is popular at these days. It costs $7.51 fees in transaction fees, so minting fees. We also reviewed this the last video, and I just want to show you that this input data from in the last video I showed you a transfer as a transfer of ETH, and there were no input data. And with this input data here, you can read or you can see that a smart contract function is called. So the mint function is called. This is encoded here, and the argument that is sent along with this mint function, it's the mint amount. You see this here in clear text, and here you can see here the argument that is passed over, which is basically 5. And so what it does is telling the smart contract, hey, I want to mint 5 NFTs, please send it over. And this is exactly what happened here. So this guy, uomo.eth, sent to this contract, which is called encryptables, a mint, so invoked the mint function with an argument of 5, telling the smart contract, hey, please give me 5 of your tokens. And when I now click on this one, I already did, will go to so this is the same basically. You see it in the left corner below my picture. You see 0x298. So this is basically the same here. 0x298, the same link behind these two things. When I click on this, we are here. I already did this. I closed this one. And you see that this contract is called encryptables. So now we are on the second type of accounts. So the first one we reviewed was externally owned accounts, so accounts that are controlled by individuals or humans. And this is an account that is controlled by a smart contract. So there is no private key, so therefore it's called smart contract accounts or contract accounts. They look the same basically, but they have a smart contract or data deployed along with them. And you see here, for example, that this is an encryptables. This name is encryptables. It currently has $2.43 in his wallet or in his account. You see the creator. So this is an externally owned account that sent, or not necessarily an externally owned account, but this account created this contract with this transaction. We could also have a look at this closely when we want to, and we see all the mints or the not the mints. So basically, we see all the transactions that took place or the interactions, basically. And you see there are a lot of mints here, and I'm not sure, but one of this, I don't know if we can find it quickly. It was 0xDC, right? So let's have a search. C27, no, wasn't it? Let me go back. It's this one. We can copy it, or let's do it the other way around. When I go, so sorry, I've now closed it. So when we now go to this transaction, so now I'm lost here. Where are we? So yeah, so this is the transaction we reviewed a few minutes ago, and we see that there are 4 mints, as I said. And when we now go back to the contract and copy this address here, we could see that somewhere in this 912 transactions, there is this one. We just saw. Oh, sorry, I copied the wrong one. Of course, this is the receiver, so this is the sender. So this UMO should, we don't have it here. Okay, it's a little bit more than 50 minutes ago because it's not on the first page. But anyways, what I want to show you is that you now see this, these interactions here, and you also see, for example. So let me go back up. So we have the contract here. We see the balance. We see the name, we see the contract creator, we see the transaction that created this contract. We see all the interactions or transactions that are that took place with this contract, and these were all mints here. Ones or here set approvals and other smart contract functions. And when we go to contract, we see the contract in clear text. This is because the project team decided to do so, so they verified the contract on Etherscan. So basically saying that the bytecode that is deployed is the same as this source code, and this is ensured by a hash and the matching hash. So this is an exact match here, and therefore this is verified, and therefore you can be sure that this smart contract you see here, so the source code, is the same that is deployed behind this address, and nobody can fake you here. And when you search for mint, and we have a look at the mint function. So this is the save mint. They must have implemented it on their own. Yeah, here one. So as I said, so this is exactly the same thing we saw in our transaction data input, and this says mint amount 5, and we say okay. So I won't go over all the stuff here, but just very quickly, you need to mint more than 1, you need to mint less than this number, and then all the stuff is going on here. So it's pretty a few ifs and a loop here, and okay, this is basically it. So this is all the mint function, and we can now see that yeah, we can now review the source code if you want to, but this is not the scope of this video. I just want to show you how you can explore the source code or read the source code, and also read all the information that is provided by the block explorers here. And you can also go to internal transactions. You'll see some events that took place here. ERC20 transactions. So, and let's go back to the transactions. Yeah, so just hurrying a little bit up because I already spoke for 15 minutes and I don't want the video to be extra long. So I will stop here. Yeah, do you have any questions on my my findings here or my explanations on this? If so, please shoot over a comment and I will be happy to answer it. And I hope you get something out of this. It's interesting to see how you can read and navigate and explore all the data that is provided via Etherscan. And other block explorers work somehow the same. So they are always some kind of a view portal to the blockchain. The data is all there, and these interfaces are providing it in a nice way so that you can click and you can navigate around and read all the stuff also in human readable style. So yes, as I said, I hope you like it, and stay tuned for more. See you.